Good morning, children. Nice to meet you again after these 3 days of short break. Hope you all had time to finish your pending work and have some festivity celebrations. And today, I think when you watch this video, you'll be watching this video after today's Zoom class, right? So I'm planning to, we have done till this in the previous video. So this much is left, which I'll be doing I would have done in the Zoom class. Okay. Just for the sake of children who missed the Zoom class, I'm quickly telling the points. You can quickly mark it. Mainly, barometer is used in weather forecast. You would have seen in news and all, they usually tell this weather forecast for the coming week for 10 days or 14 days, and they'll say next 3 days there'll be heavy rainfall, or next 3 days it will be very hot. Now all this weather forecast they make with the help of an barometer. They measure the atmospheric pressure of a place, and based on the atmospheric pressure they will be able to decide two things: temperature and then presence of moisture. Temperature, presence of moisture. Presence of moisture determines the amount of rain, and temperature, that determines whether it's going to be hot or cold or what kind of thing. Okay, so the two conclusions that you have to remember is density of air decreases with increase in temperature. Density of air decreases with increase in temperature. Humid air, if you remember, humid air is less denser than dry air. Okay, humid air is less denser than dry air. So we can say density decreases with increase in temperature. Opposite relation. Density decreases with increase in temperature. Okay, and also with increase in amount of pressure. With both it has opposite relationship. Okay, with temperature and with moisture. Okay, now based on this only they do this. Okay, consequently atmospheric pressure gradually decreases as the temperature or the pressure of presence of moisture increases. In the sense, if it's going to be a very hot day, then also temperature will atmospheric pressure will decrease, and then okay, and even if it's presence of moisture means chances of rain is also there. When that is also there, then the atmospheric pressure might decrease. Okay, now based on these concepts they have given some conclusions. Okay, there are 5 conclusions. You just have to know the conclusion and then what does it indicate. Okay, if the barometric height suddenly falls, if there is a quick fall, sudden fall in that, then it indicates the coming of a storm or cyclone. Coming of a storm or cyclone. Moisture content has increased so much, that's why there is a sudden fall. Second possibility, gradually falls. This is sudden fall, means the previous day it was showing 76 centimeter of Hg, and then the next day it's showing say 65. Like there was a sudden fall. Whereas if it is gradually falling, the sense 76, then 74, then 72, like that, then it indicates moisture is increasing and then there is a possibility of rain. Okay, then the third possible conclusion is a gradual increase in barometric height. These were decrease, sudden decrease, gradual decrease. Now gradual increase in barometric height means moisture is decreasing. That means coming of a dry weather. Sudden rise in barometric height means flow of air from that. So it's an extremely dry weather. Okay, sudden rise, extremely dry weather. If there is no abrupt change, yesterday the pressure was 76 centimeter of mercury, today also it's 76 or 77. Okay, there is no abrupt change, then weather will remain unchanged. Can you understand? So the questions that you get based on this is something like this. How do the following indicate in a barometer regarding what do the following indicate in a barometer regarding weather? Gradual fall, sudden fall, gradual rise, and all that. Okay, then last topic is altimeter. So what is altimeter? It is a aneroid barometer which is used in aircrafts to measure altitude. Okay, when an aeroplane is flying, constantly they'll be displaying that we are this much feet above the ground, that they calculate using an altimeter, which is basically an aneroid barometer. Okay, now we'll see the principle of altimeter, principle on which an altimeter works. Since atmospheric pressure decreases with increase in height, therefore, barometer which measures the atmospheric pressure can be, since the atmospheric pressure decreases with increase in height, a barometer which measures atmospheric pressure can be used to determine the altitude of a place above sea level. So barometer itself can be used to determine the things, but you don't need the pressure, we need the height. So what they'll do is, its scale is calibrated. If it's an altimeter, its scale will be calibrated in terms of height of ascent, with height increasing towards left, because the atmospheric pressure decreases with increase of height above the sea level. Now see this one here, they have just shown the height of mercury column in terms of height of mercury column. There it will be in terms of height of ascent. So here it will be increasing, this side it will be increasing because atmospheric pressure will decrease as you go high. So on the left side it will be decreasing, okay, with height increasing towards left, because atmospheric pressure decreases with increase of height above the sea level. Okay, the question can be, how is it calibrated? Okay, now we start with a new chapter, chapter 5, Upthrust in fluids and Archimedes principle and flotation. Upthrust, have you heard this word before? Upthrust, upthrust. Now you know thrust is force. So upthrust means upward force acting on a body. Upward force acting on a body exerted by, upward force exerted by fluids. Basically it is liquids and gases both. Okay, liquids and gases both can exert upward force. Upward force exerted by fluids, that is liquids and gases, acting on a body is called as upthrust. So from the name itself you can okay, so you have all observed this. If you try, okay, you take a bucket of water and then you have a tin can, empty tin can, okay, a Coke can, it's which is empty. Okay, so you can understand it's very light, so it will float in water. What you're going to do, you're going to push it. Okay, you're going to push with your hand, you're going to push it inside water. When you do that, you will feel something is pushing you up. I hope all of you would have had this experience. Anything light, you try to push it inside, it will be as if something from inside is pushing you up. That is upthrust. That is called upthrust. The upward force exerted by water on this body is called as upthrust. Okay, so on each and every body in the surface of earth, so as I told you, upthrust is exerted by both liquids and gases. So suppose I'm dropping a ball from a height. Okay, I'm dropping a ball from a height. Even this is under upthrust. Even an upthrust is acting on this also, exerted by the air. Okay, it will be coming down. Okay, in this case, because the weight is more, if it's a solid stone, because weight is more, it will quickly come down. Okay, we'll see what happens. On the other hand, if you put a paper, okay, if you just leave a paper from a height, you know how it will go? It will keep swaying here and there, and it will take time to reach the ground. Why? The upthrust is pushing it up. It wants to come down, but because it is light, this upthrust is dominating and it is pushing it up. So this will be dancing and dancing and dancing like that, and finally it will reach. So the point is, every body on the surface of earth is under the under the influence of this upthrust by the surrounding medium, be it liquid or air. This is air around and all that. Okay, even we are under the influence of upthrust, but because our weight is so so much more. Okay, so air is exerting an upthrust on our body also, but our weight is so much, this is so dominating that this will cancel the effect of this and we are able to walk easily. Hope you got the idea of upthrust, children. It is the upward force exerted by fluids, okay, both liquids and gases, on a body. So that's the definition. Upward force exerted on a body by the fluid in which it is submerged is called the upthrust or buoyant force. The other name for upthrust is buoyant force. Okay. The property of liquid to exert an upward force on a body is called buoyancy. That force is buoyant force and the phenomena is called buoyancy, or the property is called buoyancy. Then they have given some examples. Pushing an empty can into water. This was what I was explaining. Pushing a cork into water. Even this cork, it's a wooden cork. It's very light. So it will keep floating. But if I try to push it inside, then there will be some force acting up. Okay. So the explanation is what I have explained. Okay. So when the can or cork is put on a body, two forces acting on it. Okay, this will come little later, children. Now we go to the note here. You can underline it. Like liquids, gases also have the property of buoyancy. That is, body immersed in a gas also experiences an upthrust. Okay. Now, this part, condition for a body to float or sink. So this simple thing that whenever the density of a body is lighter than the density of liquid, it will float, and whenever the density of body is more than the density of liquid, it will sink. Okay, but why does it do and all that? There is a separate chapter, the next chapter, called flotation. Okay, so I've written here, will be done in chapter 6. So this part I'm not touching now. Okay, till this we'll be doing it in the next chapter, so I don't want to do it now. Okay, now, so about upthrust, we are going to see, so definition we have seen already. Okay, so definition of upthrust, then unit of upthrust, then reason for upthrust. Okay, then fourth, formula for upthrust, and fifth, factors affecting upthrust. Okay, so we are going to study all these topics. Definition we have done, unit, reason, formula, and factors affecting. Definition we have done already. Unit, what do you think will be the unit of upthrust? It is a force. So what will be the unit? Newton. Okay, Newton or kgf, or CGS unit will be dyne or gram force, because it is a force. Okay, now the thing is, the order is little different. Okay, he has given the factors first, then okay, I would like to okay, fine. Characteristic properties we will be doing. Okay, unit of upthrust being a force is measured in Newton or kgf. Okay, this will come a little while later. Then reason for upthrust. We are going to the reason for upthrust. Okay, what is the reason for upthrust? Now, suppose we have taken a cylinder which is floating. Okay, it's floating in water. Okay, and the top surface is at a height h1 and the bottom surface, lower surface, is at a height h2. Okay, the top surface is at a height h1 from the surface of liquid and the bottom is at a height h2 from the surface of liquid. So what happens? There is a difference in pressure. So the pressure that is exerted on this surface will be due to this height. You have to consider the height of liquid column above it. So let's take the pressure on top surface as P1. Okay, on the top surface pressure is P1 And you know the formula H1 rho G. Okay, because of height H1, pressure P1 is acting on the upper surface, and that is equal to H1 rho G. On the lower surface, which is at a height H2 from the surface of water, we have to see the height from surface of water. Okay, so the pressure P2 that is acting here, P2, will be due to height H2, H2 rho into G. H2 rho into G. Now, because of this difference in pressure, so simple logic, you can tell which pressure will be more. Definitely P2. Why? H2 is greater than H1. Lower surface height will be greater than upper surface height. Therefore, P2 will be greater than P1. Okay. So, this pressure will be always more than this pressure. So, you know that pressure is directly proportional to force. Pressure is force upon area. So, if P2 is greater than P1, F2 is greater than F1. That is, force exerted in an upward direction on the lower surface will be greater than force exerted in a downward direction on the top surface. Okay, so that leads to the concept of upthrust. That means this force acting upwards is more than the force that is acting downward. So that's the reason why we call it upthrust. The upward force acting on a body immersed in a fluid. That's the reason for upthrust. Okay. See how to write in words. When a body, say a block of area of cross section A, is immersed in a liquid, pressure P2 exerted upwards on the lower face. Okay. See the words very carefully. Pressure P2 exerted upwards on the lower face of the block, which is at a greater depth, is more than pressure P1 exerted downwards on the upper face. It's important to mention the direction. Okay, P1 is acting in downward direction, P2 acting in, we are considering P2 acting in upward direction. Now, so P2 is greater than P1 because H2 is greater than H1. That was the first point. Thus, there is a difference in pressure between the lower and upper faces. Since force is pressure into area, that is, force is directly proportional to pressure, the difference in pressure on the two faces causes a net upward force. That is upthrust. P2 minus P1 into A on the body. Okay, it's because this upward force is dominating. This is greater than this because this is at a greater depth. We say that there is a upward force acting on a body. Is it clear, children? So if they ask you reason for upthrust, you have to write these 3 points. Now, formula for upthrust. Okay, it's very simple in the sense, see, we have done till this, right? So we said P2 is greater than P1. So what will be the difference in pressure? P2 minus P1 will be H2 rho G minus H1 rho G. That will be H2 minus H1 into rho into G. Now let me take the height of the cylinder to be H. So H2 minus H1 is H because the height of cylinder is H. This is H2, this is H1. If we subtract, I get H rho G. So I get this upthrust, okay, pressure, this is upward pressure, okay. The upward pressure is H rho G, but we want upward force because upthrust is basically a force. And we know that pressure is force upon area or force is pressure into area. So this is pressure, but we need force. So pressure into area. Pressure is H rho G multiplied by, let us take area of the cylinder to be A. Okay. Now, height into area. What is height into area? It becomes volume. If you remember, height of a body into area of the body will give us the volume of the body. And so instead of H into A, I write V, rho G. And I write here Vs, volume of solid, and this rho is rho L, density of liquid into acceleration due to gravity. So this brings us to the formula of upthrust. Okay, formula for upthrust is volume of solid into density of liquid into acceleration due to gravity. Now, why is it important to write solid? Because there is a liquid also here. It has also a volume and it also has a density. And there is the solid, which it also has a volume and density. Okay, in the formula, this volume I have to take volume of solid, density I have to take the density of this liquid into acceleration due to gravity, that is 9.8. Okay, now in the book the mathematical proof is given here. You need not study it. Okay, they don't ask you the proof, you just have to go through it. All that you have to know is this formula. This is the formula for upthrust. Okay, and I have slightly changed it, Vs rho L into G. Okay, V suffix S, rho suffix L into G. Volume of solid multiplied by density of liquid multiplied by acceleration due to gravity. This is the formula for upthrust. Okay, after the formula, it leads to factors affecting. Once you know the formula, you can decide about the factors affecting. What are the factors? Volume of solid, and density of liquid. Density of liquid. So, here comes the conclusion. That is, factors affecting upthrust depends on two factors: volume of the body submerged and then density of liquid, and both are directly proportional. Okay, both are directly proportional. Okay, now there's something called characteristics, and that is also basically factors. See, three characteristics they're talking about. What are they? Larger the volume of the body submerged, greater is the upthrust. This is one factor. Inside the fluid, more the density of fluid, greater is the upthrust. This is also another factor. This we'll be seeing later. Now, one portion, that is flotation, I'm not doing it now. We'll be doing it in the 6th chapter. So right now I'm going to tell you about these two characteristics, which is basically factors. Now the thing is, you will have reasoning questions based on this. Okay, one question is, this also you'd have observed: when a bunch of feather and a pebble of same mass are allowed to fall in air, pebble falls faster than the bunch of feathers. So from a height, you're dropping. Okay, you're standing in the first floor of the building. Okay, and you're dropping a stone or a pebble, and then you're a bunch of feather. Both are at the same height above ground. Same height h above ground. Okay, in one hand you're dropping a pebble, and in the other hand you're dropping a feather. Which one do you think will reach the ground first? And another thing is given, both are of same mass. Okay, their mass is same, but what do you think about their volume? You know, pebbles density is very high, stones density is very high, and you know that feathers density is very less. And what is the relationship between density is equal to mass upon volume? Mass is the same, so volume is inversely proportional to density, or density is inversely proportional to volume, or volume. So what is our conclusion? First conclusion is, because they are of same mass, volume of feather will be greater than volume of pebble. Can you understand? Their mass is same, but just take like a 200-gram pebble, maybe just a small stone. But if you take 200-gram feather, it will be such a big bunch of feathers. Volume will be so much because its density is so less. I hope you're able to imagine. The pebble might be so small, but feather volume will be so high. So that is the first conclusion. Okay, same mass, density of pebble is greater than density of feather. So volume of feather, opposite relation. So it is. Now we know that upthrust, what is upthrust formula? Volume of solid into density of liquid into G. Now both are falling in air. Medium is same. Both are falling in the same air. So medium is same. G is also going to be same. So only thing, upthrust is proportional to volume of solid. So which is having more volume? Feather is having more volume. Okay, so upthrust on feather will be more. In the sense, upthrust pushing the feather will be the upward force on the feather is more than the upward force on the pebble. So that's the reason why feather doesn't immediately come down. You can see it floating here and there because there is a constant upward force that is trying to push it up. It tries to come down, but there's upthrust pushing it up. That's why it won't reach the ground immediately. But the pebble, upthrust is there, but it is much less than its weight. So it quickly comes to the ground. So that is how the reasoning question will be. Okay, when a bunch of feathers and a pebble of same mass are allowed to fall in air, pebble falls faster than the bunch. Give reason why. Reason is that upthrust due to air on pebble is less than that on the bunch of feathers because volume of pebble is less than volume of feathers. Okay, so first you have to write this one. Mass is the same, but density of pebble is greater than the density of feather. So volume of feather is greater than volume of pebble. And then upthrust is directly proportional to volume. So on the feather, upthrust will be more. So it will take time to come down. There is another conclusion here which can also be asked. In vacuum, both of them will fall together. Will there be upthrust in vacuum? Suppose imagine I'm dropping both of them in a vacuum. Maybe in a lab, you created a vacuum condition and I'm dropping both of them. And in that case, both will be reaching ground at the same time. Why? Why? Because there is no air and there is no upthrust at all. Because they both have the same mass, the weight will be same and both will be coming down at the same time. Okay, so in vacuum, both the bunch of feathers and pebble will fall together because there is no upthrust. Okay, then when you come see the density of liquid, more the density of fluid, more the upthrust. So they have given one example. Cork A is placed in water and cork B is placed in glycerin or mercury. So you know that mercury or glycerin's density is more than density of water. So what happens? So upthrust will be more in glycerin or mercury. So what happens? It will be immersed more. In both the cases, it will be floating. Suppose this is water. Okay, and the cork is floating like this much portion inside on a glycerin. And the same cork, if I put it on a glycerin, because density of glycerin is greater than density of water, upthrust by glycerin will also be greater than upthrust by water. Okay, so upthrust by glycerin is more. So weight, in the sense, very less portion will be inside water. In this case, more portion is submerged because upthrust is less, whereas in this case, upthrust is more. So more portion will be outside. Okay, the volume of cork B immersed in glycerin is smaller as compared to the volume immersed in water. Volume immersed in the glycerin is less than volume immersed in water because density of glycerin is more than density of water. Okay, children. So reason is that density of glycerin is more than density of water. In whichever case upthrust is more, in that case very little portion will immerse. Can you understand? It will push it up, so very little portion will be immersed. In cases where upthrust is less, then more portion will be immersed on the thing. So that is the principle that we are using here. So I think we have finished everything. Definition, unit, reason, formula, and factors affecting upthrust. Okay. So I hope you all have marked everything. Give reason. First possibility is this one. Second possibility is in vacuum both the bunch of feathers and pebble will fall together. Then this one can also be a reasoning question. Then reason for upthrust points. Then formula for upthrust. Then this one I'll be doing in the next class. Then factors affecting upthrust. I hope you have understood till this. Thank you, children.